So let's talk about lenses. A lens is a curved piece of glass or some other transparent material that we're going to use to focus light and generate some images. So let's see how it goes. Suppose that I've got an object out here in air, and then I've got a piece of glass that's curved outward like this in a convex way. All right. We always, with a lens, have a principal axis. If light comes in exactly along the principal axis, it goes straight through the lens with no deflection whatsoever. So that's the principal axis. Now, most of the time, if it's a lens, it'll have two sides. The principal axis needs to be perpendicular to both because light needs to go all the way through without being deflected. All right, let's see what some light rays coming from this object do. So we come in like that. All right, now, at the glass, the light is going to refract. In order to determine how it's going to refract, we have to give ourselves a normal. And then we say, well, this is a more crowded hallway than that. So that means that the light is going to bend toward the normal. All right, so that's fine. What about one that comes, let's see, what about one that comes down like this? Well, down here, our normal looks like this. Remember, the normal has to be perpendicular to the lens. So the light is going to bend toward the normal. Notice what happens. The light beams are coming together. So this is going to give us light rays that come together and hit somewhere along the principal axis, it seems like. So the focus is the place where rays that come in parallel to the principal axis go. So this focus will be right over here, where this hits the principal axis. All right, so this is called converging. When I have convex glass, light rays converge after they go through. All right, what happens if I've got a piece of glass that's like this? Concave. Well, in this case, we're going to do the same thing. So let's go ahead and draw some light rays. Here's one. It's going to come down like this. All right. And then again, we need our normal. Our normal is that way. And again, we bend toward the normal. Just like this. All right, now notice this light ray is not going towards the principal axis. So something different's going on. Let's give ourselves a light ray that's parallel to the principal axis. Again, I need a normal, and I need to bend toward the normal. Like that. So this guy is causing the light rays to diverge. So concave glass is called diverging, all right? Because light rays come in and then they split apart. All right, now notice that this light ray appears to be coming from somewhere like there. That's called the focus of a diverging lens. So for convex, the focus is the place where rays parallel to the principal go. For concave, the focus is the place where rays parallel to the principal axis appear to be coming from. If I was looking on this side, I would see the light coming like that, and I would just continue that line straight back. And that would be where the focus is. All right? All right, now let's say that we've got some real lenses, and that means they got to have two sides to them, right? You're not just going to have a lens which consists of a piece of glass that goes on forever, right? And you just don't. All right, so let's say that I've got glass like this. Well, the glass is convex on both sides. So that means that this side is converging, this side is converging, and therefore this glass will be a converging lens. All right? How about over here? Well, on this side, the glass is concave And on the other side, it's concave too. So both sides are concave. That means it's diverging on both sides. So this is a diverging lens. All right? What about here? So these were easy because it was convex, convex, concave, concave. What about here? On this side, it's convex, but on this side, it's concave. I don't know. So we've got convex, and then on this side, concave. So we need to know whether this lens will ultimately converge or diverge light. Here's the idea. This side is more curvy. This side is flatter. It doesn't curve as much. Now, if it would be completely flat, then it wouldn't converge or diverge. So that means that in this case, the concave side is not as strong as the convex side. So the two together are going to combine to make a converging lens. All right, and then let's look at the last one. The last one, again, we've got converging, and on this side we've got diverging or concave. But which one's more curvy? Well, in this one, it's more curvy on the diverging side. And that means the diverging wins, and this will be a diverging lens. All right. Now, it's really, really, really easy once we've seen these examples to do one in general. Because all we need to say is it converging or diverging? Well, geez, is it fat in the middle or fat at the top? Fat in the middle or thin in the middle? If it's fat in the middle, then it will be a converging lens, all right? And what that will mean is that light converges at focus. All right? What about diverging? Well, if it's thin in the middle, then it's going to be a diverging lens. And it's going to diverge the light. All right? Now remember that with a diverging lens, light that comes in parallel is going to come out and it's going to appear to come from the focus. And that's lenses.